Question 21. Eli is choosing between two investment options. Option 1. Depositing a single amount of $40,000 today, earning interest of 1.2% per annum compounded monthly. Option 2. Depositing $1,000 at the end of each quarter, earning interest of 2.4% per annum compounded quarterly. A table of future value interest factors for an annuity of $1 is shown. Part A. What is the value of Eli's investment after 10 years using option 1? Option 1 describes depositing a single amount or a lump sum of $40,000 at the start, earning interest of 1.2% per annum compounded monthly. So that means there are 12 compounding periods per year. So to find the value of Eli's investment after 10 years using option 1, we need to apply the future value formula. That is, FV is equal to PV times 1 plus R to the power of n, or FV is equal to A times 1 plus R to the power of n. These two formulas are identical. The only change is rather than using PV, we can use the letter A, which represents the principal or the amount invested at the start. FV represents the future value of the investment after n compounding periods. N is the total number of compounding periods, and R represents the interest rate per period. Now in this case, N is equal to 12 compounding periods per year times 10 years, which equals to 120 periods in total, and R is the interest rate per period, which equals to 1.2% per annum divided by 12 compounding periods per year, which equals to 0.1% per period. So the future value is equal to 40,000 times 1 plus 0.1% in brackets to the power of 120, which equals to $45,097.17, correct to the nearest cent. Part B. What is the difference between the future values after 10 years using option 1 and option 2? Option 2 describes an annuity of $1,000 invested at the end of each quarter, earning interest of 2.4% per annum, compounded quarterly. Note that there are 4 quarters in a year, which means there are 4 compounding periods per year. So to find the total number of compounding periods, which is represented by the pronumeral capital N, we take the number of compounding periods per year, which is 4, and multiply that by the number of years that this investment runs over, which is 10. So capital N is equal to 4 times 10, which equals to 40 compounding periods. R represents the interest rate per period, and that's 2.4% per annum divided by 4 compounding periods per year, which equals to 0.6% per quarter, or 0.006 in decimal. The next step is to locate the corresponding interest factor that corresponds to capital N equals 40 and R equals 0.006 using the table. So referring to the table, row capital N equals 40 is here and column R equals 0.006 is here. Find where the column and the row intersect, which is this cell here. So the interest factor to use is 45.05630. And we can use that value to find the future value of the investment using option 2. And that's found by taking the amount invested per quarter, which is 1,000, and multiply that by the interest factor we just found, which is 45.05630, which gives a future value of $45,056.30. And the difference is $45,097.17, which is from Part A, minus $45,056.30, which equals to a difference of $40.87.